In this video, we'll come up with our third formula for product to sum. So notice in the last video, we did sine, sorry, we did sine, cosine, and cosine, cosine. This one's going to produce our sine, cosine. So notice what we did is we took a formula, the two formulas from yesterday, and I'm going to minus one of them instead of adding them like we did in the previous video. So if I subtract them now, I get cosine of alpha minus beta minus cosine of alpha plus beta. And that's going to equal, okay, then we just got to be careful here. That's going to go with that. And then we're going to 2 that minus minus. So I don't know where that 2 went. Sine alpha, didn't mean to make a fish there. Sine beta. And then again, we have a formula there. If I want for just the sine, I can divide each side by 2. Resulting in this. All right, so now we have a formula for all of them. All right, sine, cosine, cosine, and cosine, sine. These two are equivalent. They just flipped them. That's really all that was. Um, you could take a look if you'd like to derive it like we've been doing. You can find out that that is that. So the key isn't to memorize, right? It's to be familiar. Most of the time in calculus courses, not all the time, they will give you formulas like this, the crazy ones. You're expected to know like sine squared plus cosine squared is 1, but these crazy ones usually calc professors like to give you a table or some kind of reference sheet or let you know that one's coming up so you'll know to look at it. All right, so this example here using our formula, I got cosine here. All right, so cosine is going to be 1/2 times cosine of the difference. So that's going to be a negative 2 theta plus cosine of the sum, which is just 8 theta. And then we know that the cosine of a negative angle just spits out the positive of that angle. And there we go. Again, it's kind of hard to see why would I ever want to do that. Well, there's a thing in calculus called integration that you'll do at the end of Calc 1. And doing this, the way it's set up, you may not know what any of the symbol here and there, what that means, but it's very difficult to do it this way, but very simple to change it and do it that way. So that's what you're doing in the future is you're learning all these. That way it will get you out of calculus problems that are pretty difficult. All right, I got an example here and then just a list of some other formulas. We're not going to derive those, but we'll see. Okay, so cosine of 11 pi over 12, cosine of pi over 12. Okay, I know that's going to be 1/2 times, and let's go back and look. Okay, it's going to be cosine, it's the difference and then the sum. So the difference is going to be 10 pi over 12, which is 5 pi over 6. And then we add them, and it's the sum. So that's cosine of, I think that's a pi. Right, then we evaluate these things. Okay, cosine of 5 pi over 6. 5 pi over 6 is the short triangle in the second quadrant. And we're doing cosine, so it's going to be a negative rad 3 over 2. Plus or minus, this one's going to be cosine of pi, which is a 1. So we get negative rad 3 over 4 minus rad 3, or no, sorry, there's no rad 3 there, 1 over 2. There we go. Right, you could put those together if you'd really like, I guess. Negative rad 3 minus 2 over 4. And there's no difference. I probably would have stopped here. Okay, last little section for these formulas. So here's some sum to product. So if we're adding the two, this is how we get to the other. We could you could take a look at those other equations above. If you were to solve them for the alpha plus beta side of it, then you actually it will work out to this formula. So if you'd like to try it, give it a shot. If you'd like to look up sum to product, how to derive it, that will work as well. I think AI will derive it for you if you'd like to look at that, if you're one of those people. So we're just using the formula now. So sine of 4 theta minus sine of 2 theta. And I'm going to go down to save some room. Okay, so that is this one, the second one. So I get 2 sine, and then it's the subtract them. So 4 minus 2 is 2 theta divided by 2 is just going to give me a theta. and then I get a cosine, and this says to add them and divide by 2, which is going to be a 6 theta divided by 2 is a 3 theta. So we're done there. Now, why would we want to go backwards? Well, there's some things in calculus that you would want to go from what I have here to, or sorry, what we have here backwards. Same as what I showed you a second ago. All right, this one, sine of 3 theta plus sine of theta. All right, that one is going to be the top one. So this is equal to 2 sine. Okay, it says to add them and divide by 2, so that's going to be a 2 theta. And then cosine, subtract them and divide by 2, that is just going to be a theta. So they're pretty easy to use as long as you know the formula. But again, my argument for at least knowing that they exist and what they kind of look like is if, for instance, if you're having trouble on homework and you go to the internet to look for how to find or how to get help, well, if you don't even know what to look for or how to describe what you need help on, it's kind of hard to know what to search. So it's the same thing with the trig thing. If I'm in a trig problem and I see this, my thought process is, oh, I know that's something else. So I'm going to go to my trig table whenever I have that and look for it. That's going to be the same for the field as well, right? You're not going to be restricted to your memory in your work for field. Okay, so there's that formula.